Sea ice has decreased. This is nothing that would be a surprise to anybody in this room. What we have in this study been concerned with is really to find out what that sea ice decline is having of consequences, not only for this ocean in itself, but also for the terrestrial realm. We all know that sea ice is associated with energy exchange, and a very important one, and that the declining sea ice is of course one of those feedback mechanisms that is of incredible importance for the accelerated warming that we are seeing in the Arctic. We also know a lot about the infrared radiation that is released, but the internal processes in the Arctic have been sort of identified as those that are the most important for the feedbacks in the climate system that makes the Arctic warming more than the rest of the world. So there's a lot of local, if you like, regional Arctic processes that are incredibly important for how the climate system is working. And we know that the sea ice is connected to processes on land. Here we have the sea ice extent on the top, and we have NDVI, which is an index of the greenness of the tundra, actually correlating quite well and indicating that there is a connection between the retreating sea ice and what is happening on land. Here we have tried to put together the carbon budget because of this greening of the tundra is of course related to carbon cycling, and here we have tried to put together the numbers, and it just indicates that there is also a feedback mechanism that comes from the sea ice, the left-hand side of this picture, towards the land, and also impacting on the processes there. So what we know about the terrestrial CO2 fluxes, just to summarize that, is that we have a lot of studies, but they are not sort of completely agreeing, but we have models that tend to agree that we will see an increase in NEP, but we have a lot of wildcards, if you like, tundra fires and permafrost melt, a lot of processes that can actually really be important. But on the whole, if we look at the picture of CO2 exchanges in the Arctic, the terrestrial scenery is actually more simple than what we have out in the ocean. There we have a lot of new processes that many of you in this room are much better at than I am, but there's a lot of complexity in the ocean part, which is really important, and we need to study more. So the disappearing of the sea ice has increased the continental shell pump, but there's a lot of new processes, if you like. This brine rejection that CERN and many of you are working with is something new and something that we should really be focusing on. And there's a lot of more research to be done. Okay, then what about methane? Now I'm sort of trying to review both CO2 and the methane story, and the methane is what is sort of more closely related to what I'm doing myself. And in terms of methane, we have some interesting atmospheric observations and atmospheric, if you like, sort of connections with what we're doing on the ground. Here we are in the atmosphere showing the atmospheric growth rate of methane over the past 20 years or so, and we see 2007 was really increasing at the high northern latitudes. And this is something that we have that has been identified as being something that is related to wetland processes and tundras in the northern hemisphere. This type of image is often portrayed like this, or sort of moved this way around, because it's really difficult to interpret what the hell is happening in the atmosphere and how it connects to what we're doing on the ground. And often we see that the atmospheric guys will rather see that this type of picture is portrayed as this, because it really is the mirror image, if you like, of the challenge in interpreting it. But we do see that there are connections to be made between what is measured in the atmosphere and what we are measuring on the ground. And this is really something that is also a developing area that is really interesting. One of the things that we have shown, and that we show in this paper that is just in press now, is that models of methane emission, dynamic vegetation models, actually actually sort of have a very strong correlation between the sea ice anomalies and the methane emission that they predict for the tundras over the past 20 years or so. So there seem to be connections. And we know these fluxes quite well, in particular in the land area. This is the wetland, these are the green arrows now that are appearing, these are the methane part, and we see that we have sort of in comparative way, we have relatively little variation in the wetland emission from methane, but we have something happening out in the near coastal ocean, and here we had a science paper recently showing significant amounts of methane in the bottom waters of the Laptev Sea, and also estimates for that this could be an increasing source just now. But the question is this something that has always been there, or is it something that has been developing or that may change with climate change? And here we have Igor, who is in this audience, and I'm hoping that we will hear more about, showing that in fact it will take a long time before the warming in the atmosphere is going to penetrate down to where these large stores of methane are, and maybe the danger for this to be released is not so urgent. So there's a controversy there that is really interesting. But the bottom line, and if we put numbers on this source, you will see that this source is varying a lot, from 1 to 12 teragrams. By the way, this is all in teragrams for carbon per year. So we have a great uncertainty there, and there's a lot to be done. The final thing is that there was recently found in the leaks of the Arctic sea ice that there is apparently also a methane release, which is really, really poorly understood. It has only been measured from the atmosphere, but it's something that may also be important, as not the least from a process point of view, that we need to understand what is actually happening in these leaks. But with overflights of the Arctic Ocean, there can actually be measured increased concentrations of methane over these leaks, and this is something that may add up to some fluxes that is significant, not by wetland emission terms, but actually really significant if they are taking place in all of these areas where there are leaks in the Arctic. So there's over there in the right-hand side of the picture, there is another arrow which has just appeared in recent years on the methane side, which we don't know the real size of, but it appears to be really important. So this sort of completes the picture that we are reviewing in this paper that is on its way out, and I'm just going to let the conclusions flow here, and then I'll take questions. Thank you.